So first what I found is the equilibrium price by setting the demand curve equal to the supply curve. Now what I do is I substitute that price I found into either the demand curve or the supply curve. Now I would suggest you substitute it into both functions. You should get the exact same number. So it would mean 100 minus 2 times 8.75 is going to give me 82.5, or 30 plus 6 times 8.75 is also going to give me 82.5. That would be my quantity demanded or quantity supplied. We know that quantity demanded equals quantity supplied at the equilibrium, right? We saw that right here. Right here, quantity demanded equals quantity supplied. Right, let's even make it more apparent here, right? The quantity demanded equals quantity supplied. So in essence, what we have here is an equation where our equilibrium price is 8.75, our equilibrium quantity is 82.5. Now, the other question then would be, how would we be able to calculate a shortage or a surplus? Well, we know the shortage or the surplus is going to exist, in this case, if the price is something other than 8.75. So then the thing to calculate then would be, what if the price was $10, for instance? Or what if the price was $3? Right? What we would then do is substitute that price into both the demand curve and the supply curve. Right? I'll do one of those, and I'll let you do the other one. Let's do 100 minus. Let's set the price at $10, for instance. When I set the price at $10, I find a demand curve where the quantity will equal 80 and a supply curve where the quantity will equal 90. We can see right here, even without graphing it out, that we have a surplus. Quantity supplied is greater than quantity demanded. Now, that's not surprising, right? Because we have a price that is higher than the equilibrium price. If we graph this out, it should all make sense here when you're graphing it out. The numbers should make sense. Is that when I have the price at $10, the quantity demanded is 80, the quantity supplied is 90, and the surplus is the difference between the two, 10. Right? And the numbers are making sense here in respect to 82.5. Okay, so the final thing that I want to focus on for this chapter is something called comparative statics. And what comparative statics involves is comparing what happens to the equilibrium price and quantity when you change the demand curve, the supply curve, or change both of the curves. So if we wanted to look at that, right, a very simple kind of example would say we have our supply curve, we have our demand curve, and that what I want to do, for instance, is what happens if preferences for the product increase. Right, so I gave you an event. Let's say I come out with a study that says that apples are good for you, right? And this is the demand and the supply for apples. Apples, the food. Right? Is that if I said that apples are good for you and it increases your preferences, first thing that you should be able to do is know that that's what's going to happen here, is that it's going to affect the demand curve. It's going to increase the demand. When we graph that out, we can see that it shifts out the demand curve. Now what does that do to the equilibrium price and the quantity? It increases both the equilibrium price as well as the equilibrium quantity. Now, I'm not going to do all of these for all the different events. I would encourage you to look at them all or graph them out on your own just for practice. But let me do another here. Let's say that we have something where the government passes a tax on the production of the product. So I'm going to write this out. I'd like you to write it out as well. If you want, you could pause the video at this point, graph it out, and then let's compare answers. Although I won't be able to see yours, so I guess it's a unidirectional comparison here. Okay. Again, I'm about to give you the answer, so if you want, you can certainly pause the video here. But if the tax went up, then the supply curve would fall. That would be represented by the supply curve shifting here, causing the equilibrium price to rise and the equilibrium quantity to fall. Now, this is rather easy if we're just shifting one of the curves. But what if it becomes more complicated? What if two events occur simultaneously? Two events that cause the demand curve and the supply curve to both change. So let's say I have both of those events happening. Let's say that I have in my Apple market a tax imposed and increased preferences for the product. So I'm going to have a supply curve that's falling, a demand curve that's rising. Now, what we're going to see here is that you're going to need some more information from me, and I may or may not give that to you. It's going to introduce something that when two curves are changing, right, a demand curve and a supply curve, then you're going to have something known as ambiguous change and unambiguous change, right? So when something is ambiguous, that would mean that there's some uncertainty. When something is unambiguous, that would mean that there's no uncertainty. Now, the uncertainty enters because you need to know the magnitude of the shift of the curve. If you don't have that information, there's going to be something that is ambiguous or uncertain. Now look what I did here. In this case here, what I did was I said, let's assume, even though I didn't give you that information, let's assume that the curve shifted in an equal proportion, equal magnitude. Then what you would see here is that the original equilibrium, it's called equilibrium 1, changed to equilibrium 2. Notice what happens here is that the equilibrium quantity does not change at all, but the equilibrium price increased. Here's what I'm going to suggest that you do.